All right, Squidlings, my paper was accepted for publication. I don't know when it's going to be published. I don't know when I'm going to be able to make a video about it, but it's accepted for publication. And I can't wait to tell you about it. But for now, this month, hey, Mr. Cat, let me give you a presentation that I gave in my lab for a seminar. The last time I'd given a seminar, it didn't feature the free energy principle. And Professor Tani said, next time make it feature the free energy principle. Now, this paper doesn't mention the free energy principle either, but I think it should. ADHD and the free energy principle. Like I usually say, I've made a couple of videos about the free energy principle. I don't like the name. I don't like the name free energy principle. We're not making free energy, and we're not saying you can't make free energy. One of those is boring, and the other one's crazy. The free energy principle says that biological agents, like you and I, us nice squids, we want to minimize a term in Bayesian statistics and information theory called free energy. I like to call it wasted energy because at least the way that I use it, we're trying to minimize the energy that we waste. Now, this free energy is equal to complexity minus accuracy. Accuracy in the sense that we want to make accurate predictions about the future, and complexity meaning that we want a stable worldview. If we, show them your butt, Mr. Cat. Complexity, meaning that when we get new information, we don't want our worldview to be constantly changing. And the tricky part is the way you can get a stable worldview is by having an unstable worldview. You want to find things that make your worldview change, because the more you do that, the more your worldview is stable and sturdy. The more difficult it is for you to find information that you can't incorporate into your worldview. So what does this have to do with ADHD? Let's find out. This paper came out in 2006. That's 20 years ago. Gosh, I'm old. Usually in the lab, we only show papers that came out pretty recently. I've shown a paper from 2024, and people rolled their eyes and said, 2024, come on. But this one, 2006, it worked in our lab because none of us are psychiatrists. We all study robots, so none of us in the lab have actually studied ADHD. So maybe I was trying to get them up to speed on some of the findings. This paper is called The Evolution of Hyperactivity, Impulsivity, and Cognitive Diversity. This paper does not mention the free energy principle, not a single time, but I think it should. So let's take a look at the paper first. What is ADHD? This is the definition from the DSM-5. The DSM is like the Bible of psychiatrists, among other doctors. DSM-5 is the most recent one. What is ADHD? Attention Deficit Hyperactive Disorder. It's a disorder class, neurodevelopmental disorder, and its definition includes a persistent pattern of inattention and or hyperactive impulsivity. Hyperactive impulsivity makes it ADHD-HI, which interferes with functioning or development as characterized by 1 and or 2. So what's condition 1? Inattention, which is 6 or more of these 9 things. I'm not going to go over every single one, but for example, someone with ADHD often fails to give close attention to details, or they're often forgetful in daily activities. When I showed this slide, Professor Tani looked around the lab and said, that's most of you. Most of the people in our lab forget daily activities. So that's inattention. Part 2, one of the other 2 classes, is hyperactivity and impulsivity. I think that's the focus of this paper, which is 6 or more of these 9 things. And I think these 9 things have a lot in common with the other 9 things, which is often forgetful in daily activities, or often interrupts or intrudes on others, like butting into conversations. But ADHD also includes that several of those symptoms were present before the age of 12. several of these symptoms are present in 2 or more settings. There is evidence that the symptoms interfere with functioning. I think that's really important because a lot of people are forgetful. A lot of people butt into conversations. But if it's interfering with functioning, that's ADHD. If it's not interfering with functioning, you're just kind of annoying. These symptoms do not occur exclusively during another psychotic disorder and are not better explained by another mental disorder. So they're very specific about what ADHD is in the DSM-5. And like I said, I'm not a psychiatrist. None of the people in my lab are psychiatrists. My mom's a psychiatrist. I'm going to run this video by her before I post it. Heritability. ADHD is inheritable. Several genes and alleles have been reliably identified as associated with ADHD. Its association with DR4D7R, I don't know what that is. I'm not an evolutionary biologist. But apparently, whatever this is associated with novelty seeking, which raises the possibility that ADHD is also selected for in evolution. We therefore need an explanation of why ADHD-HI is seen in only a minority of humans. If there's an evolutionary advantage, why is it only in some humans, not all of them? One thing I'd like to bring attention to on this page, novelty seeking. I just described the free energy principle where in order to get a solid worldview, you need to find new information. You need to be information seeking, novelty seeking. So I think ears in the lab perked up when I mentioned this. The paper does say that there are a lot of problems with ADHD. We mention major risks to the individual only briefly as they are extensively treated in the literature. So, I mean, people know there are problems with ADHD. The fact that it impairs functioning is literally part of its definition. So there's a lot of papers about that. Among those difficulties include education and career difficulties, 20% increased use of emergency medical services. That's interesting to me. I guess if you have ADHD, sometimes you need to get in an ambulance. Modern society tends to see uncontrolled people as deviant, and ADHD is comorbid in our present society with many psychiatric disorders, most of which decrease reproduction. Decreasing reproduction. Well, I guess if you're going to talk about evolution, you have to talk about reproduction. Mr. Cat, this isn't necessarily the best time. Every time I talk to my computer, he's like, "Who are you talking to? Pay attention to me." What ADHD may benefit? DR4D7R may impose a degree of novelty seeking that is a benefit in certain styles of society, particularly women-dominated farming. Mr. Cat, don't touch that. Don't. It's on my microphone, Mr. Cat. And a hindrance in both hunter-gatherer or urbanized society, rather than becoming a problem in increasingly advanced societies. So sometimes it's a problem, sometimes it can be a benefit. Preemptive exploitation of the environment would be particularly beneficial in groups that underwent repeated evolutionary or migrational divergence. So if you're migrating, it can help to have people preemptively exploit things that you don't know about. Maybe those things are good, in which case they found something good. Or maybe they're bad, in which they taught you something that you should avoid. This may be the reason for DRDF7R's exceptionally high prevalence in South America, where unexpected or empty ecological niches would reward the more innovative new arrivals. I don't know why they mentioned South America. Mr. Cap, this is not the time. Okay, well, I've given this presentation before, so maybe I don't need to see the screen. There are social benefits from mistakes. Exploitation by an individual can be a major benefit to his social group. Possible benefits include testing social limits, overcoming superstitions, and performing dangerous experiments. Children with ADHD-HI do things they shouldn't. They burn their hands on the stove. They eat poisonous berries and fall out of trees. They do not focus on their classwork, and they break the rules in games, which doesn't sound like it's a terribly good thing. But all these physical and social mistakes provide useful lessons for the majority, while the majority remains safe. Much less often, but possibly more importantly, children with ADHD-HI discover something advantageous that the other children would not. Now, I think that's the free energy principle right there. You gotta explore. You need to understand the world around you. And sometimes that means you have to do really stupid things. So in order to sort of judge this, in order to judge why do we have ADHD and why do we only have a little ADHD in a minority, they performed 2 simulations. I'm not entirely sure what they mean by simulations. I don't think these were physical simulations. If they were, I think they would provide pictures of it. I think these were more statistical simulations. Now, the simulation they ran was the changing food task, where there are groups of agents which need to forage to get food. And some of that food might be poisonous. So we'll talk about that one first. But then after that, they did another version of the changing food task, where it was an evolutionary version where agents could reproduce and die of old age. So this changing food task, macaques and rats appear to alternate between searching by themselves and monitoring the discoveries of their neighbors. So if you're in a group, sometimes you focus on getting food for yourself, and sometimes you watch your neighbors and see what they're eating, and if they die of poison, then you know you shouldn't be eating that. So in this experiment, they had 4 groups of 40 individuals. One group was 0% unpredictable individuals. One was 5%, one was 25%, and one was 100% of individuals which were unpredictable, which had high randomness level, which I think are supposed to represent people with ADHD, just doing things that maybe they shouldn't do. And sometimes by doing that, they'll find things that other people can do. People in these groups may die of malnutrition if they don't eat enough, or poisoning if they eat things that they're not supposed to. And the food sometimes changes, which is why it's called the changing food task, I suppose. So sometimes food is okay. Sometimes the researchers will just change it so that food's poison now. And in this circumstance, the predictable group with 0% ADHD representing randomness only eats safely. They only eat things that they know are safe. And therefore they die of malnutrition because they're not eating enough. On the other hand, the unpredictable group with 100% random individuals, they explored unsafely, meaning that they died because they ate poison. There is cat hair all over my face. Oh my gosh. The 5% unpredictable group performed the best. They had the most surviving agents. They had agents which actually ate enough, and agents which didn't tend to eat poison. So unpredictability helps, but only as a minority. You can only have some people being too exploratory. The evolutionary version of that simulation, what does this mean? They repeated the same simulation, except individuals age to death, so they have a time limit, and they reproduce with partners, maybe even partners from different groups. They pass on mixed genes to offspring and occasionally mutate. So again, I'm not entirely sure how this simulation worked. I think it's more of a statistical simulation, but on top of that, groups that grew too large were split into different groups. Groups that died were replaced. So what happens here? If foods change quickly, evolution preferred unpredictability. Evolution preferred groups where the agents ate all over the place and explored and found out what was poison and what wasn't. Agents which were more predictable or more unpredictable reproduce more than agents in the middle. I'm not sure how this is reflected in the simulation, but I suppose this means that agents are either very predictable, always eating safe things, or very unpredictable, eating whatever they can. So groups without unpredictability go extinct. They starve to death. And therefore, unpredictability is difficult to completely remove. It's best to have a minority of people who are unpredictable, even if the food is pretty dependable at the moment. So they conclude, the severity of ADHD is usually limited by the need for people with it to both engage in tasks that their compatriots will learn from, with exploration and novelty seeking, and share the information they have obtained. And that's the free energy principle as far as I'm concerned. This is a community complexity value, where some agents in the community are able to explore and thereby find things that shake up the worldview until it's stable again. The cost of including an unpredictable minority in a stable environment is small. It's okay to have a minority of unpredictable people. That's okay compared with the cost of lacking that minority in an environment which is constantly changing. So if the environment is stable, you still got to keep them around. This offers an explanation for the difficulty in removing DR-D4-7R from the population after it has outlived its evolutionary usefulness. It always helps to have some amount of ADHD minority. I'm not sure I like the phrasing of that. Why are you trying to remove a gene or an allele? I don't know. That sounds a bit sus. So let me sort of pair this with the free energy principle. This is based on a paper that I wrote that is published. I made a video about it. It's about ducks, which are exploring a maze. I wanted them to be mice or rats. I couldn't find 3D models of mice or rats, so I used a duck. I made a curiosity value derived based on the free energy principle, which caused maze exploration through self-motivated information seeking. That sounds to me a bit like ADHD. So if we look at some of these mazes, these are agents which had no entropy and no curiosity, meaning that they didn't reward themselves by doing random things. They didn't reward themselves for finding new information. And we can see they tended to choose the exit on the left. These are trajectories of different ducks after training. The exit on the left is easy to find, and it gives a small reward. The exit on the right, it's farther away, there's an obstacle in the way, but it gives a higher reward. And we can see these agents, after training, they were choosing the easy exit, because it's hard to find this exit way over here. We can see on this plot, this is the proportion of agents which were choosing which exit after 500 epochs of training, the x-axis being how long these agents trained. And you can see, obviously, they found the easy exit on the left first. And then they tended to stick there. When they found this exit, they stayed going to just that exit. And a few of them found the better exit. Can you hear that? That's the American Air Force up there. They pass by quite a bit when you live in Okinawa. All right, I think they're passing over. Okay, the agents with curiosity after training, you can see a lot of them are choosing the better exit. They had to explore to find it. So agents with curiosity got bored of the easy exit and instead found the better exit. You can see here, overtraining. A lot of them found the easy exit. Of course they did. It's easy. It's right there. But after a while, they got bored. They would rather find no exit at all rather than find the easy exit. Because finding no exit at all, that's exploring. They could get their own reward by finding things, by finding new information, which increased complexity by changing their worldview and giving them a more accurate worldview. And in doing so, they found the better exit. They found the better exit so much more often. So, could ADHD be compared to this idea of curiosity and entropy based on the free energy principle? And when I told the lab, let's discuss, I think the general consensus was that based on the way I described ADHD in this slideshow, it seemed less like curiosity and more like entropy. It seemed more like ADHD was all about doing random things rather than doing things specifically to see what information they could get from it. So, what do you think? Do you have ADHD? Do you think you'd get bored of taking a lesser exit? Do you think you might get bored of good food and trying new food, even if it might be poison? Well, I don't know. I mean, that paper came out 20 years ago. Maybe we've learned a lot since then. But I'm glad that I was able to give a presentation which tied the free energy principle to something which never mentioned the free energy principle. I think that helps people understand what the free energy principle is. So, Squidlings, go out and experiment, but don't eat any poison. Please, please. See you, folks.